Hi everybody. This lesson 3.2 is going to introduce you to the quadratic formula as well as graphing quadratic functions. Okay, we're going to look at how to find the x-intercepts, which we've already been talking about, the y-intercept, the vertex, which in other words is the point where the u-shape in the parabola is either at its lowest point or its highest point, okay, depending on where the graph sits. Okay. Before we do that, last lesson we talked about completing the square, and that formula works well for solving any quadratic function, but it does take several steps. What we're going to do is take that completing the square method a step further, and we're going to do some algebra. Okay, so starting with this first part of the lesson, we're going to do some algebra to develop the quadratic formula. Okay, for those of you that have seen the quadratic formula, it's for solving the x-intercepts of this graph. In other words, the points here where it crosses the x-axis. Okay, if you label these axes, it'd be x horizontally and y vertically. Okay, so we're going to start with our basic equation. Ax squared plus bx plus c equals 0. Okay, so nothing special, the exact same equation we've started with. And instead of putting numbers to it, we're going to keep it like this, okay, to develop a universal formula that can be used. The first step we're going to do is we're going to divide everything by a, okay, because we don't want this term, just like we had in the past, having any coefficient behind it. So dividing every term by a, the a's will cancel on the first term, and we're left with x squared plus b over a times x. Okay. The next item we're going to do is move our constant, which is now c divided by a, to the other side, meaning it becomes negative c divided by a. So our equation here becomes x squared plus b over a times x equals negative c over a. Okay, so nothing is different except we don't have numbers to plug in here. Okay, so these are the same first two steps that you would have done to solve a completing the square question. All right. So now we're going to do the same thing we had done, which our next step was to take focus on the coefficient behind the x term, which is b divided by a. And we're going to do the same thing. We're going to take it, b divided by a, and we're going to divide it by 2. Okay, so that's the same as either multiplying it by 1/2, or you could write it as b over a divided by 2. Whatever one makes more sense to you. I find that this format works better for most students. So you're going to cut that number in half. And if you're multiplying fractions together, you simply multiply the numerators together and multiply the denominators together. So that becomes b divided by 2a. And remember, after we divided it in half, we squared it. Okay? So what that means is to square it, we're simply going to put brackets around it and say squared. So that term, if you remember from completing the square, was added to both sides of the equation. So you can see I've taken it and I've added it to the left-hand side, and I've added it to the right-hand side. All right? So that's all that I've done, okay, up to this point. Now, if you remember, on the left-hand side of the equation, it always ended up being a perfect square. In other words, this term that we developed, b divided by 2a, was, in essence, the factor that we need to solve this. So you can factor this to become x plus that term we found, b divided by 2a, all squared. Okay? And just to show you why this works, okay, that's the same as x plus b divided by 2a times x plus b divided by 2a. Now using, remember, FOIL, we multiply our first terms, which is x times x, or x squared. Our outside terms, x times b over 2a, which is b divided by 2a times x. Our inside terms, which are b over 2a times x, again, b over 2a times x, and our last two terms, which is b over 2a times b over 2a, or b over 2a squared. So simplifying this, you get x squared. Adding these two terms, you're adding b over 2a and b over 2a. That just becomes b divided by a, because you're adding two halves together, plus b over 2a squared. Okay, so you're arriving at the same solution you had, okay, sitting here at the start, okay? So next, what we need to do is, we're trying to arrive at a neat and tidy solution. So on this right-hand side here, we have these two fractions that we're going to combine together. And the first step to do that is we have to simplify the second term. In other words, expand it out by squaring both the top and the bottom terms. So what we arrive at is negative c over a, that remains unchanged, plus our first term, or our second term, is in the numerator b squared, okay? And in the denominator we have, you square each term. So 2 squared, which is 4, and a squared, which is just a squared, okay? So having that, what we need to do is to combine these on the right-hand side into one fraction, okay? So remember, what we had before was negative c over a plus b squared over 4a squared. Now to combine them under one fraction, what we have to do is multiply each of them by the other term's denominator. In other words, this first term gets multiplied, so negative c over a gets multiplied by the denominator of the second term, 4a squared. And the first term, or the second term, b squared divided by 4a squared, gets multiplied by the denominator of the second term. So what we're left with when we combine these is negative c times the other term's denominator, 4a squared, plus the second term, b squared, multiplied by the first term's denominator, which is a. And then what you do to combine these is you divide it by both the denominators. So a times 4a squared, okay? That's just combining the two denominators together. And what you get is you start to be able to simplify things, okay? So you end up with, you have an a and an a here that you can factor out. So I'll show you this in a few steps. So this becomes, you can factor out an a from both the first and second terms. This becomes a times negative 4c times a. Okay, I've just rearranged it to make it a little simpler. Plus b squared. And that's divided by, combining those terms, 4a squared times a is 4a cubed. So this a will cancel with one of these a's, and this will just become a squared. And I'm going to rearrange the items in the top so that the negative term is second, okay? Just from aesthetics, it looks better. And what you arrive at is b squared minus 4 times ac divided by 4a squared. Okay, that's just simplifying this expression we have here. So what I'm going to do now is I have two expressions. I'm going to take the square root of both sides. So we have the square root of x plus b divided by 2a squared is equal to the square root of the second term, b squared minus 4ac divided by 4a squared. And on the left-hand side, it's just x plus b over 2a because you're taking the square root of a function that's squared, remember from radicals. On the left-hand side, the numerator can't be simplified, so it's simply plus or minus b squared minus 4ac, the square root. The denominator, the square root of 4a squared, okay, is equal to the square root of each of those individually. Well, the square root of 4 is 2, and the square root of a squared is a. Okay, so we're left with just 2a. so that 2a is placed in the denominator. What you'll notice is both of our terms have 2a, okay? So our last step would be to combine those, and we do that by bringing the b over 2a term to the right-hand side. So this became x is equal to the square root of b squared minus 4ac plus or minus divided by 2a minus b over 2a. So when you have two fractions that have the same denominator, you can simply just add their numerators together. And if you do that, you arrive at this answer here, negative b, which is the term we had right here, plus or minus that square root term, b squared minus 4ac divided by 2a. Okay? This is the formula that will be able to solve any of your quadratic expressions. Okay? And we're going to go over some instances later on in this lesson. But just a couple items to note. This is known as the quadratic formula, or quadratic roots formula. You might have heard of that. The terms a, b, and c are the or in this case, a and b are the coefficients. A is the coefficient of the x squared term. B is the coefficient of the x term, and c is the constant at the end. Okay, so not multiplied by any x terms. And like I mentioned in the last lesson, these roots actually show you the x-intercepts. Okay, so when you solve this equation, you're going to get two roots. One using the positive square root of b squared minus 4ac, and one using the negative square root of b squared minus 4ac. Okay, and what they correspond to, again, are the points where it crosses the x-axis. So this is the x-axis, this is the y-axis. And these are the points that you're solving for. And like I said, they're known as the x-intercepts. Okay? This formula is an important one for you to know, especially moving forward for this upcoming test. So let's look at a few examples, okay? Example 1, solve 5x squared plus 7x plus 2 equals 0 using the quadratic formula, okay? So we know the quadratic formula solves for x coordinates, and it's equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay? In this instance, a is equal to the coefficient of the x squared term, 5. B is equal to the coefficient of the x term, which is 7. And c is equal to the constant in this case, which is 2. So this formula becomes a simple plug-and-play exercise. So x is equal to negative b, which is 7, plus or minus the square root of b squared, 7 squared, minus 4 times a, which is 5, times c, which is 2. And that is all divided by 2 times a, which is 5. So if we simplify these out, we get x is equal to negative 7 plus or minus the square root of 49 minus 40 divided by 10, which is negative 7 plus or minus the square root of 9 divided by 10. So the square root of 9 is simply 3, which means your two roots are x equals negative 7 plus 3 divided by 10, or x equals negative 7 minus 3 divided by 10. In the first case, you get negative 4 over 10, which is negative 2/5. In the second case, you get negative 10 over 10, which is negative 1. Okay? So remember, these are the x-intercepts. So they are the points where they cross the x-axis. So if you were writing these in terms of coordinates with x and y, you would get negative 2 over 5 and 0, and negative 1 and 0. The reason the y-coordinate is 0 is because it's where it's touching the x-axis, remember? And at this point here, y is 0. At every point along this x-axis, y is 0. Okay? So our second example, solve negative 2x squared plus 6x plus 4 equals 0 using the quadratic formula. So we know a is equal to negative 2, b is equal to 6, and c is equal to 4. Okay, so negative 2, 6, and 4. Our quadratic roots formula, solving for x-intercepts, is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Substituting in our values here, x is equal to negative b, which is negative 6, plus or minus the square root of b squared, 6 squared, minus 4 times a, which is negative 2, times c, which is 4. And that's divided by 2 times a, which is negative 2. Simplifying this, we get x equals negative 6 plus or minus. This becomes 36 plus 32. Okay, negative 4 times negative 2 is positive 8. Or times positive 4 is positive 32. And that's divided by 2 times negative 2, which is negative 4. Okay? So simplifying this, we get x is equal to negative 6 plus, what that is, what's the square root of 68 divided by negative 4, or negative 6 minus the square root of 68 divided by negative 4. Okay? If we solve these, again, see now you're going to see they don't factor nice and evenly. We're going to get some long decimals. So if we do this, in our first case, our answer is negative 0.5615, just plugging those numbers in your calculator. Or in the second case, x is equal to 3.5615. Okay? In either case, at this point, it becomes a matter of plugging it into your calculator. Okay? Okay, so now that we've talked about the quadratic formula and we've seen how it works, I want to move into graphing these quadratic functions. But before I do that, I want to talk about the Cartesian coordinate system. So Cartesian coordinate system is a fancy way of saying graphing these functions in 2 dimensions. Okay, in other words, x and y. Okay, so the way the coordinate system is broken up is we have 2 axes, the x-axis, which runs from left to right here, and the y-axis, which runs up and down. Okay, the positive y direction moves upwards, so this is positive. The negative y direction moves down. Similarly, the positive x direction moves to the right, and the negative x direction moves to the left. For the x-axis, this line here, okay, represents a y-coordinate of 0, okay, because it's neither positive, which is this direction, or negative, which is this direction. Similarly, on the y-axis, any point on that axis has an x value of 0, because it's neither in the positive direction, which is to the right, or the negative direction, which is to the left. The point in the very center, which is known as the origin, is actually at 0 and 0. Okay, so for points, we always label them with brackets, like I've shown you in other examples, with the x-coordinate first, so the origin would be 0, 0. Okay, so the x-coordinate is the first coordinate, and the y-coordinate is the second coordinate. So when you solve the quadratic formula, and you obtain values of x equals negative 1 or x equals 2. Okay, so let's say those were your 2 functions. What that means is the point where it crosses the x-axis are when x is negative 1, or this point here, and when x is 2. Because it's always when the y function equals 0. Remember, we're solving for the x-intercept. In other words, where it intercepts through the x-axis. Okay? So when we did the quadratic formula, you'll remember our formula was ax squared plus bx plus c equals 0. Well, the reason it equaled 0 is because this is actually the y coordinate in our normal function. Okay, so when it equals 0, it means it has to be on this line here. And remember, the quadratic formula was being used to calculate the x-intercepts. So what you're going to see now, moving on, is the same equation, ax squared plus bx plus c, but instead of equaling 0, it's going to equal y. Okay, so y is going to equal ax squared plus bx plus c. That's going to allow us to graph these points, right? Because when we graph in 2 dimensions, one variable is always a function of the other. So in other words, in this case, y is a function of x. We normally show it as f of x, okay? So that's going to be important when we use this coordinate system now to graph these quadratic functions. Okay, so looking again at this quadratic formula now, we're going to develop a couple additional points in addition to the x-intercepts that we can use in order to graph these functions, okay? The first is the constant, which is the value, which actually is just simply the value c here, okay? The reason for that is, remember, our equation now is y equals ax squared plus bx plus c. That's the general form of the equation when we're not trying to find the x-intercepts. So remember back to our Cartesian coordinates, the y-intercept is where it crosses this y-axis here. And remember that all those points are where x equals 0, right? Because it's neither in the positive direction or in the negative direction, okay? So if x is 0, then these first terms would both become 0 because they're a constant multiplied by 0. So y would just simply be equal to c, or the value of the constant. So our y-intercept is a relatively quick value for you to find. Okay, writing it in terms of points, it would be 0 for the x-coordinate and c, or the value of the constant term in the equation for the y-coordinate. The second term is the vertex, which, remember back I said that these are parabolas. So they're sitting as a parabola, something like this, or even inverted. The vertex is this point, either the highest point for the parabola or the lowest. Okay? And this piece of the quadratic formula, the minus b divided by 2a, is actually the x-coordinate of the vertex. So your x-coordinate is negative b over 2a. Your y-coordinate is if you substitute that value of x into your equation. Remember, y equals ax squared plus bx plus c, and solve for the y-coordinate. All right? So that gives us now, with all of these, we have the x-intercepts. That's 2 points. The vertex, which is another 1 point, and the y-intercept, which again is another 1 point. So in total with this, what that means is we now have 4 points that we can use to graph this on the Cartesian coordinate system. And remember, when you have these points, you can then draw lines in between, because like I said, this function will always come out looking like this parabola style shape. Okay? The last term we're going to talk about is arguably the most important term within this quadratic formula. It is known as the discriminant. Okay, so this term under the square root sign, b squared minus 4ac, that is the piece that's known as the discriminant. And that determines what type of roots you have. Okay, so there's 4 different options I'm going to talk about. And on the next slide, I'm going to show you what that means in terms of where the parabola is physically located within the Cartesian coordinate system. The first is if your discriminant is a perfect square. In other words, if you do all the addition and subtraction and the b squared plus 4ac term comes out to something like 4, or 9 or 16, because those are all perfect squares, meaning that if you take the square root of them, you end up with a real number, okay? So the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4. Okay, you get a real rational number here, okay? The second option is that the value is positive, but it's not a perfect square. Okay, so the example of that would be the square root of 3 or the square root of 17, any of those numbers. For example, the square root of 3, okay, is 1.73205. Okay, so it keeps on going and going and going. So it's not a perfect square like a 2, a 3, or a 4. Okay. In both those situations, you get two roots that are different, but they are distinct. Okay, so you have two roots, and in other words, the parabola goes through the x-axis twice. The third option, okay, is if it's 0. Okay, so if it's 0, then what happens is you only get one root. Okay, but it's exactly the same. Okay, so both your roots would be -2, for instance, or some whatever number it is. That happens when the vertex of your parabola is the only point that touches the x-axis. Okay, so it only really goes through there at one time. The last instance is where it's negative. So if you have the square root of -2 or -11, that is one that can't be solved. Okay, so it means that there's no real roots. And why that happens is if you have a parabola that sits up here. Well, the vertex is above the x-axis, so it never crosses this piece here. Okay, so there are no real roots. Those are called complex numbers, and they cannot be solved. All right. So like I said, in each one of these instances, you will come up with a different solution. Okay. So for a perfect square and positive roots in general, you see that it crosses at two distinct points. Okay. The difference being in the perfect square, it's crossing at perfect points right here at 2 and 3. Easy for you to see where they are. In the positive roots, you'll notice that maybe it crosses close. This is a little above 4. And in this case, maybe around 0.4, 0.5. Okay, -0.5. So they don't cross at those exact locations, but they still do cross the axes. You can see when it's b squared minus 4ac equals 0, you only touch at that vertex. Okay. And when it's negative, like I said, there's no roots. In other words, the parabola sits above this x-axis. So it never will cross. Okay, so you draw that parabola, all right, but it'll never cross this piece right here. Okay, this is all determined based on that discriminant value. Okay, that b squared minus 4ac. Okay, it really tells you a lot about how that function is going to look before you even plot all these points and graph it. Okay, so understanding that means it's easier for you to diagnose whether you've calculated the points properly and whether you've drawn the graph correctly. So our first example, for the function y equals 2x squared plus 7x minus 2, determine a, the x-intercepts, b, the y-intercept and the vertex, and c, the graph of the function. Okay, so we'll graph it here on the right. I've given you this on the side here. Again, you can follow along, pause this, and do it and graph it yourself and then compare. Notice the one subtlety here. We're no longer dealing with the quadratic formula. So this is back to a normal function. Y is a function of x. Y being, okay, up and down, remember on this graph, and x being left to right, with the positive x being to the right and negative x to the left. And this piece in the middle being the origin 0, 0. Okay, so this is a function y, which is a function of the x variable. Okay, so it varies as x changes. So we'll start with the x-intercepts. All right, and again, that involves the quadratic formula. So part A, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a, where a, b, and c, remember this is ax squared plus bx plus c. So a in this case is 2, b is positive 7, and c is negative 2. Okay, so we can substitute these in here for each of the variables. So we have negative b, which is 7, plus or minus the square root of 7 squared minus 4 times a, which is 2, times c, which is negative 2. Okay, and that is all divided by 2 times a, which is 2. All right? So we can now take this step by step, first by simplifying each of these and then solving to find the roots. Okay? If we do that, what we end up with is negative 7 plus or minus the square root of 7 squared is 49. And the remaining terms, negative 4 times 2 is negative 8 times negative 2 is positive 16. So this ends up being plus 16 all divided by 4. So what this means is 49 plus 16 is 65. So we have our roots are either negative 7 plus root 65 divided by 4, or negative 7 minus root 65 divided by 4. Okay? If you calculate those out, I'm going to move just to the top here. Okay? What you end up getting is x is equal to 0.27. That's for the first root here. Or x is equal to negative 3.77. Remember, because these are the x-intercepts, the y-coordinate is 0. So our 2 points then are therefore 0.27 and 0, and negative 3.77 and 0. Okay? So those are the x-intercepts. For part B, the y-intercept and the vertex. Remember, the y-intercept is 0 and c being the value of the constant here. So in this case, it's simply 0 and negative 2. The vertex, all right, for part C, remember, the vertex is the point. The x-coordinate is negative b divided by 2a. Remember that as this piece in the quadratic formula. The y-coordinate is this function, okay, or f at the point negative b over 2a. So starting with the point, okay, so x is equal to negative b over 2a, which in this case is equal to negative 7, which is b, divided by 2 times 2, which gives you negative 7 over 4, or negative 1.75. Okay? To solve now for the function, we have to substitute in the x-coordinate. So y is equal to 2 times negative 1.75 squared plus 7 times negative 1.75 minus 2, and that's just 2. Okay, sorry, I almost wrote something or something out for that. So if you calculate that out, you get y is equal to negative 8.125. So your vertex, therefore, is your x-coordinate, negative 1.75, and your y-coordinate, negative 8.125. Okay, so we have 4 points here, and we can start by graphing each one of them. Okay, so the first point I'm going to graph are the x-intercepts, so 0.27 and 0. So you look at our coordinate system, this is a positive number, so it goes 0, 2, 4, 6, and 8. And each of these graph lines in between is an even distance. Okay, so in this case, since there's 4 of them in between 5 points, there's about 0.4 in between, just in the one that I drew. So we're a little between the first two. That's 0.1. Okay, so that is 0.27 and 0. Okay, The next point is negative 3.77 and 0. Again, we're going in the other direction. We're going this way in the negative x direction. We're almost at negative 4, but not quite. So we can call it right here. Okay. And in this case, we'll write negative 3.77 and 0. Our next coordinates are the y-intercept, okay, which is 0 and negative 2. Well, negative 2 is written on here, so that's pretty self-explanatory. 0 and negative 2. The last item to draw is the vertex, which is negative 1.75 and negative 8.125. So again, going to the left, we're going to go through here, all right? So we're about here, we'll call it. And then we'll go down towards negative 8.125. Okay, so we'll call it about this point here. Okay, so in that case, this point is negative 1.75 and negative 8.125. Now, what you'll notice here is this is a parabola, meaning it's a U-shaped function. So if we draw simply a parabola between those points like that, you'll see that it mirrors. So this vertex, you can consider it to be the exact center of it. Okay? So whatever you have on the right-hand side here, in this case, we're drawing that function, you mirror it on the left-hand side. Okay? And your function will continue on and on. Okay? Usually I put arrows at the end to tell you it continues on. All right? So I drew a rather bad line here. I'll just repeat it. So that's what the function will look like. All right? Remember, you can usually draw between several points on the one side, and then what you're doing is mirroring it on the other side for the parabola. Okay? So our second example, for the function y equals x squared minus 3x plus 2, determine a, the x-intercepts, b, the y-intercept and vertex, c, graph the function. So starting with part A, okay, remember again, to find the x-intercepts, it's using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac divided by 2a. So in this case, we have a is equal to 1, okay, the coefficient behind x squared. B is equal to negative 3, the coefficient behind the x term. And c is the constant, which is 2. Okay? Substituting these values in, we get negative of negative 3 plus or minus the square root of negative 3 squared, which is b, minus 4 times a, which is 1, and b, which is 2. Or c, sorry, which is 2. Divided by 2 times a, which is 1. Simplifying this, we get negative 3 times negative 3 is just 3. So we get 3 plus or minus the square root of negative 3 squared is 9. And 4 times 1 is 4 times 2 is 8. So 9 minus 8 divided by 2 times 1, which is 2. So what we end up here is 3 plus or minus the square root of just 1 divided by 2. In this case, a perfect square. So that means that x is equal to either 3 plus 1 over 2 or 3 minus 1 over 2. Okay? So in this case, again, moving back up here, x is equal to either 3 plus 1 is 4 divided by 2 is 2, or x is equal to 3 minus 1, which is 2, divided by 2, or x is 1. So our x-intercepts are therefore 2 and 0 and 1 and 0. Okay? Remember, because the y-coordinate is 0. For b, the y-intercept and the vertex. Remember, the y-intercept is simply 0 and c, which is the constant in the equation, or 0 and 2. Okay, since the constant c here is 2. Next, the vertex. Remember, the vertex, the x-coordinate is negative b divided by 2a, or in this case, negative 3 divided by 2 times 1. So 2 negatives make a positive, and 2 times 1 is 2, so this is simply 3 over 2, or you can write it as 1.5. So the y coordinate is simply the equation with this x value substituted in. So y is equal to x squared, which is 3 over 2 squared, minus 3 times 3 over 2 plus 2. Again, you could use the decimal number and just put this in your calculator. I'm going to just do it using fractions. So 3 over 2 squared, remember you square the top and the bottom term in the fraction, the numerator and the denominator. That becomes 9 over 4. Minus 3 times 3 over 2 is 9 over 2 plus 2. If I convert all of these to the same denominator, what I get is 9 over 4 minus, in this case, 18 over 4, multiplying them both by 2, plus, in this case, 8 over 4. Okay, all I did there was convert them to the same fractions. Again, you can use your calculator. It's totally up to you. So 9 over 4 minus 18 over 4 is negative 9 over 4, plus 8 over 4 gives us a value of negative 1/4. So our coordinates for the vertex are therefore 3 over 2 and negative 1/4. So now we have our 4 points. We can now place them on our graph. So remember, positive x coordinate to the right, negative x to the left, positive y going up, and negative y going down. So if I will start with the x-intercepts. We have 2 and 0, and 1 and 0. Okay, so about halfway through here. For the y-intercept, we have 0 and 2. Okay. And for the vertex, what we have is 3 over 2, or 1.5, and negative 1/4. So 1.5 is going to be halfway in between these 2 points, and negative 1/4 puts us down here. Okay. So with those 3 coordinates, we can start drawing our parabola. Remember, this is a mirror image at the vertex, right? So whatever we draw on one side, we can simply draw on the other. So in doing that, we'll arrive at something like this. Okay. Again, I don't expect your parabolas to look perfect. I do expect you to plot the points appropriately and draw the approximate image of it. All right. Our next question, for the function y equals negative x squared plus 4x minus 1, again determine A, the x-intercepts, B, the y-intercept and vertex, and C, graph the function. What you're going to see here is your A value is negative. That's going to actually change how your graph looks. It's actually going to flip it into the other direction. Okay, so that means that it's going to be pointing downwards instead of upwards with the parabola. But we'll see that. We'll see that with how the numbers play out. So starting with this, all right, A, the x-intercepts. So for part A, we start with the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac divided by 2a. So in this case, a is negative 1, okay, behind the x squared term. B is 4, positive 4, the number behind the x term, the coefficient. And c is the constant, which is negative 1. Okay, so if I substitute those values in, I get negative 4 plus or minus the square root of 4 squared minus 4 times a is negative 1 and c is negative 1. And that's divided by 2 times negative 1. Okay. Simplifying this, I get negative 4 plus or minus the square root of 4 squared is 16. And the second term, negative 4 times negative 1 is positive 4 times negative 1 is negative 4. So we get 16 minus 4, which is the root of 12. And that's divided by negative 2. So we end up with either negative 4 plus the root of 12 over negative 2, or negative 4 minus the root of 12 divided by negative 2. Okay? Now, if we solve this, we get that x is equal to either 0.27 or x is equal to 3.73. Okay, so our coordinates for this are therefore 0.27 and 0, and 3.73 and 0. Okay. For part B, the y-intercept and the vertex. So the y-intercept, remember, is the point 0 and c, where c is our constant here. So that's simply 0 and -1. For our vertex, remember x is -b divided by 2a. In this case, we have -4 divided by 2 times -1. Okay, so -4 divided by -2 gives us +2. If we substitute that in to solve for the y-coordinate, y is equal to negative of, in this case, 2 squared plus 4 times 2 minus 1. So we end up with -4 plus 8 minus 1. Okay? And if we do that, -4 plus 8 is +4, minus 1 is 3. So our vertex is therefore 2 and 3. So with these points, we can plot each one, starting with our x-intercepts, 0.27 and 0, okay, about here. Then we have 3.73 and 0, again about here. And for our y-intercept, we have 0 and -1, puts us here. And our vertex, 2 and 3, okay? So if I draw this, we're going to get something like this. And remember, because it's a mirror, we can draw the same image on the other side, okay? So it looks something like this, okay? Okay, so our last example. For the function y equals 4x squared minus x plus 2, determine A, the x-intercepts, B, the y-intercept and the vertex, C, the graph of the function. So the intent with the 4 of these is to show you slightly different graphs, right? So in this case, we're going to start with part A. Okay, so the x-intercepts are using the quadratic formula, which is -b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, in this case, a is 4, okay, the coefficient behind the x squared term. B is -1, the coefficient behind the x term. And c is 2, okay, the constant that sits at the end of the equation. Substituting these in, we get negative of -1 plus or minus the square root of b squared, which is -1 squared, minus 4 times a, which is 4, times b, which is 2. And that's all divided by 2 times a, which is 4. Simplifying this, we get -1, so 2 negatives make a positive, +1, plus or minus the square root of -1 squared is 1, minus 4 times 4 is 16, times 2 is 32. So 1 minus 32 is -31, and that's divided by 2 times 4, which is 8. So we can see here, you can't take the square root of a negative number. Okay, and the reason for that is the square root of something is the same number multiplied twice. So 2 times 2 is equal to 4. So the square root of 4 is equal to 2. In this case, a negative number can only be achieved with a positive number multiplied by a negative number. So those are not the same number. Okay, so +2 is not the same as -2. All right, +2 adds 2 to something, -2 removes 2 from something. So this is what's called a complex number. Okay, so that means that there's no roots. And what that means is that the vertex, in this case, because this value is positive, the vertex must be within these two quadrants. It does not pass the x-axis here. Okay, so it will never cross it. All right, and we're going to see exactly why when we see the remaining points. Okay, so there are no roots. So at the end, you can write no real roots. Okay. B, the y-intercept and vertex. Okay, so the y-intercept is 0 and c, in other words, the constant value. So this is just simply 0 and 2. For the vertex, remember the x-coordinate is negative b over 2a. In this case, negative times negative 1 divided by 2 times a, which is 4. Or in this case, 1 divided by 8. So that means your x or your x coordinate is 1 over 8. Your y coordinate is calculated by substituting 1 over 8 into the equation. So we get y equals 4 times 1 over 8 squared minus 1 over 8 plus 2. Again, I will do this in fractions. You are more than welcome to just substitute these into your calculator and solve. So if we do this, we get y equals 4 times 1 over 64, squaring both terms, minus 1 over 8 plus 2, which is 4 divided by 64, can simplify to 1 over 16. And converting all of them to the same fractions, we get minus 2 over 16, and plus, in this case, 32 over 16. Okay, so 1 over 16 minus 2 over 16 is negative 1 over 16, plus 32 gives us 31 over 16, which if you converted that to a decimal is 1.94. So our coordinates here are 1 over 8 and 1.94. And 1 over 8 can be converted to a decimal, which is 0.125 and 1.94. Okay, so we know the vertex. We do not have any x-intercepts, but we do know the y-intercept. So I will start with the y-intercept, which is 0 and 2. Okay, so this is the y-intercept. And the vertex is 0.125 and 1.94. So it's very close to here. It's about right there. Okay, it's about there. And those are the only 2 points we know. So what we know is we can kind of fan it out as a parabola. And remember, it's a mirror. So whatever you do on the left-hand side, you can do on the right. Okay, so this parabola will look something like this. Again, these are the rare instances, okay, where they're sitting above the x-axis here. The more points you have, the easier it is to graph. In this case, it's more difficult to graph because we do not have all those points. That being said, you could decide that you want additional points to graph this more accurately. And if you do that, you could say, well, I want to know what it is when x is 2, when x is negative 2, etc. And you can simply substitute those values in and find the corresponding value of y. And you can do that, and you could then build additional points. Okay, so you're building additional points to this graph that you can then add to draw it more accurately. Okay, so you're not limited to these. It's just they are points that you can find in every instance to solve. Okay, so that's it for this lesson. All right, so make sure you look at these practice problems. Okay, they will be very helpful for you to get used to doing graphing, especially if you're trying to figure out more or less what the graph looks like for your upcoming test. Okay, do you have any questions? Please send me an email or ask in the tutorial. Thanks, everybody.